Hello everybody, welcome. Today we will solve a simple two supported beam, one of the easiest type of this one. The easiest when your two supported beam is parallel with your coordinate system. So if we choose, for example, this one, x and y axis lines, and this will be our coordinate system. Now the beam is parallel with the x axis line. Okay, two supported beam because we have two support points, but the two support points are different. The first one in the left side is a hinge, and inside the hinge we find only one force, but we don't know the angle between this force and the axis line. So instead of calculate a force and one angle, we calculated the two component. So if this is the A point in the left side, the A support point, we can talk about two forces, AY and AX component. So there we will find one force, the A force, but we don't know, we don't want to figure it out, the angle of this force. So instead of this, we use the projection of this force, the X and Y projection. The second support point on the right side is a simple roller support. Inside the roller support, still we have one force only, but we know the direction. We don't have to figure it out the angle because inside the roller support, the force direction every time is perpendicular to the ground, to the movement of this, and the movement inside this roller support. So now, because I drew here a horizontal line as the ground, so now we know inside this roller support point, the force will be parallel with the y axis line. So we have three unknowns. Okay, use in these examples, inside these examples, we will use only concentrated forces. For example, we have a perpendicular 10 kilonewton. This force is perpendicular to the beam, so exactly parallel with the y-axis. We will use one force, and the angle between the beam and the force can be 30 degrees, for example. Okay, we need some distances here. Can be anything, of course. When you start the practicing, I suggest use some good and beautiful number for yourself. So for example, 2 meter, 3 meter, and I don't know, for example, 5 meter, and later you can use a real number, what you can find in the in the life, in what you can find in the structures. Okay, we know the distance, we know the angle. Okay, let's start. Okay, let's see the method. I suggest in this case, when you solve something like that, the easiest type of the two supported beam, first write the summation of MA equals 0 equitation. So all of the moment around the A point will be 0. Not the A letter is the important, but this point will be your hinge point where you can find the two unknowns. So can be any letter, B, C, D, doesn't matter. But start with this moment. Why? Because every time if you have a two supported beam, you will have a hinge and a roller support. And inside the roller support, anytime you will have just one unknowns. So if you write this moment, you will find the roller support unknown every time. So this can be the first step. The second step, what I suggest, use another moment equation, submission of moment around the B point, so around the roller support. In this case, this is the best, because not the easiest, but the best for the results, because the first and the second equations is not depends from each other. So maybe you did something wrong things in the first equation. Maybe the results is wrong. Maybe you forget one of the forces or something problem is there. But doesn't matter for the second. So the second equation and the results of the second equation still can be good. And after, if we did and solved both of them, we will check them, the results, with the summation of Fy. This is when you use an addition for all forces what is parallel with the y-axis. So this is not a moment equation, this is a simple force equation. We will add all of the forces what are parallel with the y-axis. And after that we will use the summation of Fx equation. That is another force equation parallel with the x-axis line, and this has to be 0, of course, as everything in the statics. Okay, let's start it. So the first summation of the moment around the A point end has to be 0 as every time. Okay, let's see one by one. I will do this from left to right. First, if you check everything from the A point, first you will see the 10 kilonewton force. And the 10 kilonewton force is perpendicular to your beam, so you don't have to divide it. This, you can imagine this kilonewton is parallel with the y-axis, so you have just y component. You don't have any x component. So only what you have to do is multiply with the perpendicular distance, is 2 meters from the A point. Now, as you see, this rotation, the 10 times 2, is an anticlockwise rotation around the A point, and I choose this as positive. Some of the books or some other videos, if you check that, maybe choose different rotation for the positive, choose the clockwise rotation, but doesn't matter. The only matter inside one equation, until you didn't finish this one, for example, you have to choose one direction to positive. Now this will be the anticlockwise, and you can't change it. So from now, because I started the equation and I choose the anticlockwise as positive, I have to keep it. So the next one, if you check the 5 kilonewton y component, that will be negative. So 5 kilonewton times sinus 30 degrees, this will be 5 kilonewton times sinus 30 will be the y component of the second force. And the distance from the A point, the perpendicular distance, is 5 meters. As you see, is opposite, so this is a clockwise rotation. This is why I marked with negative pre-mark. Okay, the by as unknown, we don't know how many is that one. We don't know the direction is up or downwards, but we have to draw something. Now I drew is going up. If it's true, inside this equation, this will be positive rotation around the A. So I have to write here by times all of the distance is 10. And if we solve this, first we will see the number, of course, the magnitude of this force. And the second thing is what we will check, the result is positive or negative number. If it's positive, that means the by direction was good. If the number is negative, that means the by, original by direction, what we did before, it's wrong. So we will turn it. Okay, let's see the by from this equation. Let's say 10 times 2 is 20, minus 5 times 0.5 times 5, so 25 times 0.5. It's a positive number, but we have to move to the other side, to the 0 side, so minus 7.5 over 10. The result is minus 0.75 kilonewton. So we got a negative pre-mark here as a result, so we have to turn the original one. So the by is not going up, but it's going down, if we calculated in a good way. Later, as you see in the method, we will check it. Now this is just a result, maybe good, maybe not. We have to continue. Let's see, moment around the B point still has to be 0. Now I will write, just to show you doesn't matter the direction, I will write the y component of the 5 as positive rotation sinus 30 degrees times 5 meters from the B point, because it doesn't matter. The only matter if you start somehow. For example, now the anti-clockwise is the positive. Everything what is still anti-clockwise has to be positive, and the clockwise has to be negative from now. So the 10 kilonewton times 8 meter will be negative, as you see. And the unknown AY will be negative too, because it's clockwise. The X components going through to the B point, this is Y is not inside in this equation. Okay, the method is the same. We will calculate and we will check the Primark. 5 times 5 times 30 sinus minus 80. This is a negative, but I move to the other side, will be positive, and divide back with negative 10, so the results will be negative, minus 6.75 kilonewton, so not up, but downwards, if is good. This is why so important. Now, as you see, the third equation will be the checking equation. Now we will check what did we do. Submission of Fy has to be 0. If everything is good, we will see 0 equals 0. Again, the positive direction is your decision because it's a new equation. Can be the up, can be the downwards. It's your decision. If you choose the up as positive direction, the AY will be negative because it's going down. The BY will be negative because it's going down. The 10 kilonewton will be positive because it's going up. And we have a negative, the 5 kilonewton Y component, so minus 5 times sinus 30 degrees. And we don't have anything else what is parallel with the Y, so if it's good, the right side has to be 0 too. Okay, let's check it. Minus 6.75 minus 0.75 plus 10 minus 5 times 30 times sinus. So yes, it's exactly 0. So both the AY and the BY are good. This is how you can check. If it's not 0, you have to find a problem. Maybe you forget something inside the equation. Maybe you did mistake with your calculator. Doesn't matter. You have to stop and you have to find it. Okay, but now it looks good. Okay, the next step is the submission of Fx. So we have to write here all of the forces without any distance. This is just a force equation, don't forget. So we have to write everything, all of the forces, what is parallel with the x. As you see, for example, the unknown Ax. Again, the positive direction is your decision. Now I choose the right direction as the positive. So everything what is going to right will be positive and everything what is going to left will be negative. As you see, we have just one other x component, what is coming from the 5, and the direction is opposite, so minus 5 kilonewton times cosinus 30 degrees. That will be the x component. If we solve this one, the Ax will be 5 times, let me see, 5 times 30 times cosinus 4.33 and some other numbers, but doesn't matter. And this result is positive, so the original direction as right, still good. We don't have to turn it. Okay, this last result, the Ax, is not checked, as you see, but if you want, you can do it. You can check this with a moment equation, for example. Just you have to be sure you choose one point for the moment what is not inside your beam. Because if you choose a point inside somewhere in the beam, the Ax will going through and won't inside in the moment equation. Okay, for that one, for example, I choose a point here under this point, exactly in the middle of the beam. But under the beam, so the vertical distance, this one, for example, is 2 meters. Okay, it's my decision. This will be a P point. You can choose anywhere, just be sure it's not inside the beam. Somewhere above or somewhere under the beam. Why? Because in this way, if you write the moment here, this equation will include the AX too. Okay, let's see. So now we will write a moment equation, summation of the moment around the P point, and still has to be 0. Because in the statics, if you remember, everything is 0. Okay, let's go one by one from left to right. Okay, let's start, for example, with the AY. 6.75 kilonewton times, from the P point, the perpendicular distance is 5 meters. Because the AY is a vertical force, you only have to check the horizontal distance. The horizontal distance is 2 plus 3, so it's 5. Okay, the direction now, as you see, I wrote everything in positive, so positive rotation, but the AY, you can see here, going down. So if you check the original, it went up. Doesn't matter, you can check the original draw, or you can keep the good results. I suggest every time, of course, the good results, because when you draw this one, the AY direction and the BY direction may be good, maybe not. As you see now, both were wrong. So use the good one, what we calculated before. If it's going down, that is around the P point, that means anti-clockwise rotation. So in my equation, the anti-clockwise rotation will be positive from now. Okay, let's see the AX. The AX going to the right side, so the rotation around the P point is a clockwise rotation. So opposite, so minus 4.33 times 2 meter. This is an AX, so we need a vertical distance. That was the 2 meter. That was my decision, if you remember. Okay, let's see the 10. The 10 kilonewton force goes clockwise. So minus 10 kilonewton times, the distance was 3 meter. As you see, the Y component of the 5 kilonewton is going through to the P point. So you won't have any distance for it. So you don't have to write inside this equation. The distance will be 0. But you have to use the X component. So, and the X component of the 5 goes anti-clockwise rotation. So positive 5 times cosinus 30 degrees. This is the X component. And the distance for this, it's 2 meter. And we have a BY. The good direction is down, as you see. So around the P point that goes clockwise rotation, we have to write as negative 0.75 times, and the distance will be 5 meters. And if we didn't forget anything, and we use the good directions and good distance, this will be positive. Let's check. If it's not positive, if it's not 0, we will find where we did the mistakes. Okay, 6.75 times 5 minus 4.33 times 2 minus 10 times 3 plus 5 times 30 cosinus times 2 and minus 0.75 times 5. The result is 0.00025. So it's 0. Of course, the more digits what you use, the give you the exact 0 results, of course. The sinus and the cosinus function, if you remember, is an infinite number almost every time. So this is why you can see the AX is not exactly 4.33, by the way. This is why it's not exactly 0 as was in the AY. The second reason, by the way, why it's not exactly 0, because we use for the checking equation a moment equation. And when you have a moment equation, every time you have to write different distances. For example, here, we know the 4.33 is just the approximate number because we have to use more digits. And we multiplied this approximate number with 2 meters. So we increased the problem. We increased the distance between the good results and the exact results. Okay, For example, if you check the last two equation, you can change it if you want. You can calculate the unknown AX with the moment equation, and you can check with the summation of fx. In this way, by the way, you will see exactly 0. So a little bit better for the good results, but longer, of course. And if you write a test in the university or somewhere else, the time is one of the most important things. So again, this is the easiest type of the two supported beam. The two supports are in the end and the start point of the beam. We used only concentrated forces. One was perpendicular, one was under angle. The method is first write a moment equation to the hinge point, write moment equation. You have to write moment equation to the roller support. After, check everything with the summation of Fy, and use the summation of Fx to find the Ax. If you want to check the Fx2, you can use another moment equation, but not necessary, of course, but you can do if you want. So you can check with this P point moment. You can check everything, by the way. If you see the summation of MP equation contains the AY, BY, and the AX at once. So if this is 0, by the way, everything is good. The checking equation is not necessary in my class, by the way, but I suggest every time, because just imagine if your BY is wrong or the AY is wrong, and if you didn't check, you won't know which one is good, which one is wrong, and later we will use these results for other calculations, or if we draw the internal force diagrams or something else. So you have to be sure, if you want to be an engineer, you have to be sure your results are good, and you can't stop until you can find the good results. Okay guys, these examples was only that one. We find everything, and everything is 0, 0 equals 0, so we finish this one. If you like this video, just use the like button, and please subscribe for the channel. Thank you, goodbye.